is not clear. I need to tell the reader what exactly we mean by geometry. It's not what we use, it's subtle. I need to tell the reader that particles are not precisely particles, so there's some discreteness, some granularity. And then I started thinking, maybe I should say when these ideas were born. So the ideas needed to understand. If I tell how they're born, and suddenly the entire history, the narration came in front of my mind. Of course, I just talk about Democritus.
Right.
I talk about Galileo. I talk about Faraday. I talk about Maxwell. What problem they were addressing, how they come out with that particular solution, and why we're using this notion now, and how this notion built up, changed, and came all the way to quantum gravity. And that is evolution of the world. At the time of Descartes, in the Renaissance, there's this idea that this is res extensa. Then Newton comes and says, okay, I got the world. It's a space, time passes, and there are some little stones that move around with forces. That's how. And then Faraday comes and, wait, you're missing something. There's a field. Okay, and Maxwell put order in the field. And then Einstein comes and said, look, the space and the time are actually mixed. So you should not have two different things. You should talk one another.
Space-time.
Space-time. And then Einstein, 10 years later, realized that the space-time is a field. Wow. Okay, now we connect the notion of field with space-time. And quantum mechanics connect the notion of a particle with a field. So unless you go through the way the things developed, you don't get them, I think.
Yeah.
So I decided to write a book without details, but with a core flow of ideas. That's how it came out.
And when that epiphany hit you while driving, I know what happened after that.
You know what happened after that? I got a ticket.
Because you were driving too fast?
I was driving too fast. It was an empty in the night highway. I was so excited.
You had the pedal to the metal?
The first chapter is going to be seen. And then at some point I hear, wow, shit. And I look at the speedometer, I don't know how you call it in English. And I'm going, 180 kilometers per hour on the highways. Oh, no. So I had to pull on the side, and the policeman said, what the hell are you doing? And I was, I just told him. I said, I'm sorry, I just was going extremely fast. The reality was I was not even in a hurry. I just got an idea how to write a book. And was so happy with that. I just was excited. And the policeman said, okay, good luck with your book, and let me go.
He let you go.
Yeah.
I'm dying to use that excuse someday. Oh, no, I was speeding because I figured out how to write a book about quantum gravity. I don't think it will work for me, but I'm glad it worked for you.
Yeah, it's good to know that works. I have a question. A lot of what you're talking about, it seems that it's very fundamental, this idea of unlearning things, both when you're writing books to encourage your readers to unlearn some things, or even in your research. I think that when we're thinking about something, we can be stuck in certain ways of conceptual thinking, or be making some assumptions and not even realize it. Are there certain strategies that you've learned, perhaps from philosophers, that encourage you to challenge your conceptual ways of thinking?
Oh, that's a very good question. I don't know the answer. The premise of your question are, I think, the most fundamental point about learning. The difficulty of learning is not to learn something new. That's easy. The difficulty of learning is to unlearn what we think we know. We're all deeply convinced that we're right about the way we see the world. Everybody, including myself. And so we just don't give up easily the ideas we have. And we don't learn unless we give up.
You wrote once that science is born from an act of humility. Is that do you mean by humility the idea that we can accept that we don't know everything?
That, but even stronger, the idea that what we think we know, we might be wrong. And so what we don't know is so much more and so large that we shouldn't rely so much on what we know. Yeah, I think humility, there's this beautiful letter by Newton. Newton was arrogant, pretentious, perfectly aware that he was the greatest thinker of his time, and 3 centuries later, we still think he's a greater thinker, maybe in science of all the times.
Mm-hmm.
He was aware of that. And at the end of his life, he writes this letter. He says, I don't know how the others are looking at me or will be looking at me, but I myself look at myself like a kid playing with little pebbles on the shore in front of the ocean of our ignorance.
Mm-hmm.
That's why he succeeded in being Newton, I think, because he was perfectly aware that there was everything to be discovered. And
so he was both arrogant and humble at the same time.
Arrogant about
arrogant
his skills, and humble. It's the mixture of the two. You can be arrogant with respect to the others, humble with respect to your ignorance, and the fact that that we might be right, we might be wrong. I've been reading this summer because we're doing an audiobook in English, Galileo greatest book. It's the dialogue of the two maximum systems of the world. It's a fantastic book. It's a book that convinced humankind, in fact, that the Earth is moving.
Mm-hmm.
And it's spinning and it's going around the sun. And it has all the argument for the Earth to move. But reading it, surprise, is that the arguments are just a few pages. The large part of the book is to convince the reader that it's possible to question what he give for granted.
Mm-hmm.
It's all about, look, you think that, but that might not be right. And give an example, give a thing. It's only when 3/4 into the book, say, okay, now you're open to the book. I haven't argued anything.
Mm-hmm.
I've just told you, consider the alternatives. Only at that point, he brings argument for the movement of the Earth, which, by the way, are wrong argument. I'm mistaken. We know that. But nevertheless, he convinced the world not by giving good argument, in fact, it isn't wrong, but by showing that there's nothing wrong in accepting that something completely obvious to you is it's not right. But that was not your question. Your question, well, what's a strategy we can go into for not being trapped in our own beliefs?
Mm-hmm.
And I don't know. I think it's because we are, and scientists are like everybody else,
right?
And more than being aware of that, keep repeating to ourselves that I don't know what's the right way of doing so.
Do you remember a moment in your earlier life when maybe physics or science itself sort of revealed to you this this new way of looking or unlearning things you may have known? Open your eyes to new possibilities? Was there a sort of a epiphany there, or was it a series of happenings?
It was a series of happening starting from when I was a student. I fell in love with science late, when I was already a university student in physics, and in studying modern physics. It was a series of shocks, like, oh my God, somehow reality is not what it seems. That became the title of my book. So it was a strong experience at that time.
Is that a phrase that you've had in your mind for a long time before the book came out, that reality is not what it seems? Is that sort of the realization you had those years ago?
The concept, yes, for sure. Somehow it grew with me in various manners. The phrase itself, I'm not sure. I think it came from the text of the book, and then I picked it up because I think it represented what was going on.
We were talking about, you mentioned quantum gravity before, and there's a line in your book, 7 Brief Lessons on Physics. It's just such a simple, short line. There is a paradox at the heart of our understanding of the physical world. And that paradox is essentially, I think, the root of quantum gravity, the paradox between general relativity and quantum mechanics. Can you elaborate a bit more on why that's a paradox? What paradox we're struggling with and why we need a solution to
it? Yes, I believe it is an apparent paradox, but it's a strikingly paradoxical the way it looks. And I think the way I describe it in that book, I'm not sure it's that book, is it's what a student of physics learns when he goes to school